Okay, very good afternoon to one and all. So, in yesterday's class, we discussed about different different type of mask layers and how to analyze these mask layers, isn't it? So now, in this class, we discuss about how to draw the stick diagram. Okay, so let's go to start how to draw the stick diagram. Okay, now I'm going to share the screen, and also we can discuss about what is the NMOS design style, and we can draw the different logic circuits, stick diagrams for the different logic circuits. Okay, let's go now. We're going to start. I'm going to share the screen. Okay. So that's the this is the NMOS design style. That means we are going to draw the stick diagram. Okay. So here, you know that what is the stick diagram basically? It is the pictorial representation of this is the pictorial representation to convey the layer information through the use of color codes. Okay, and we discuss about the different layers in the structures. Okay, so basically we're having different layers, that is the N diffusion and polysilicon, metal one, and these are the different. And also we are having thin arc layer. Okay, all these things, nothing but we can consider different layers in the MOS structures. Okay, now let us consider the stick diagram. So it can be used to convey the layer information through the use of color codes. Okay, so that is the stick diagram. So how to draw the stick diagram? And for this case, we are having NMOS design style. Let us go to the NMOS technology and how to draw the stick diagram in NMOS design style. Okay, NMOS design style, how to draw the stick diagram. So NMOS design style is nothing but, so how to draw the stick diagram in NMOS design style. Okay, so there is nothing but NMOS design style. Similarly, we are having CMOS design style. That means how to draw the stick diagram in CMOS design style. Okay, once you know the procedure here, you can easily draw the stick diagram. Okay, so let us assume that this is the NMOS design style. In this design style, N diffusion can be represented by a green color. Okay, N diffusion, that is we can call it the thin arc region. Basically, the thin arc region is nothing but N diffusion and transistor channels and also active layers. So all these are nothing but thin arcs. Okay, thin arcs. And to represent this thin arc layer, we are having green color. We are going to use green color. Okay, whenever you can see the green color, you can identify that this is nothing but the transistor channel and also N diffusion and active layers. Okay. Similarly, we are having another layer is called polysilicon. Basically, polysilicon is used to identify the gate of the transistors. Okay, so therefore, in the stick diagram and also in the layout diagram, this polysilicon plays a very important role. So therefore, the polysilicon with the color code for this polysilicon is red color. Okay, we are going to use the red color to identify the polysilicon. Similarly, we are having metal one layers. Okay, because we are going to connect the layers, and also we are going to use the VDD and VSS line and signal lines. So in that cases, we are going to use the metal lines. Okay, so here the metal lines is nothing but we can use the color code for this metal one layer is blue color. Okay, we are having different type of metals, metal one, metal two, and metal three like this. So here, in case of NMOS design style, we can use only one metal, but in case of CMOS design style, we can use metal one as well as the metal two. Okay, we'll discuss afterwards. Okay. Similarly, we are having implant. This is the very important in case of NMOS design style. Okay, to draw the stick diagram in NMOS design style, this implant also plays a very important role. Okay. Now, why we are going to use implant, we'll discuss now. Okay. Similarly, whenever the two different layers are joined together, okay, whenever, remember, this is the most important point. Okay, whenever two different layers, okay, So we are having N diffusion, we are having P diffusion, and we are having polysilicon, and we are having metal. These are the different layers we are having. Okay. So now in this case, whenever the two different layers are joined together, because we are using here in NMOS design style. Okay. In the NMOS design style, we are not using P diffusion. Okay. So therefore, we are having only N diffusion, metal one, and okay, that is the metal one. Okay, N diffusion, metal, and different contacts now in this case. Okay, so therefore, polysilicon also. Okay, N diffusion, polysilicon, and metal one. So these are the layers we are using in the NMOS design style. So therefore, the implant is the most important thing in this case. Okay, and this implant is used to identify. Okay, this implant is used to identify depletion mode transistors. Remember, okay, this implant is used to identify depletion mode transistor in the NMOS design style. So the color for this NMOS design style is yellow. Okay, yellow color is used to identify the implant in the NMOS design style. Remember that point, right? So next, you're having contacts. Okay, whenever the two different layers are joined together, okay, we are going to use contact. Okay, so we are going to use the contact in this case. Remember that point, right? So therefore, these are the different layers we are using in the that means we are having green color, N diffusion, red color for polysilicon, blue color for metal one, and yellow for implant. And contact is, you are having two colors in this case. Okay, because contact will be two types. One is a buried contact, another is a identity contact. Okay, so basically the contact is in case of stick diagram, we are using black color. Okay, we are using black color, and also we are using brown color also. Okay, we are using brown color wherever your two different layers are joined together. Okay, particularly in this case the structure. Okay, we are going to use the brown color. So therefore, just observe in this case, black color is used to ordinary contact and brown color for the buried contact. Remember this point. Okay, buried contact. And remember, so how to form a transistor? Okay, you're having different layers. Okay, N diffusion, green color, and polysilicon, red color. Okay, so here, whenever a polysilicon crosses the diffusion layer, okay, whenever the polysilicon crosses the diffusion layer, a transistor is formed. Okay, remember that point. Okay, see the wording here. So transistor, whenever the polysilicon crosses the N diffusion, if there is no crossing of polysilicon, when there is no polysilicon crossing for this diffusion layer, no transistor will be formed. So there must be crossing. Okay, that must be polysilicon must cross the N diffusion. That is the main thing. Okay, so that is the, for example, assume that this is the N diffusion. Okay, assume that here this is the N diffusion and this is the polysilicon. Okay, so just see the encoding color. Okay, that is encoding for different NMOS process. Okay, the stick encoding. Okay, you are having the green color and red color. Okay, blue color. Okay, these are the stick encoding a monochrome condition. There is no without any color. Okay, this is the rectangular ball. So the width of this rectangular ball is very thin. Okay, so you can draw here monochrome. But compared to this monochrome style, you can use the color code, color pencils or colors. Then it is very important here. Okay, so remember in the examination, better to go for color codes. Okay, don't use crayons and sketches. Okay, don't use crayons and sketches for color. Better to go for only color pencils. That is the very important. Okay, only for examination. But in other ways, in a home or in practice cases, you can use either crayons or sketch pencils, also no problem. Because in examination, better to use color pencils because there is no image on the next page. Okay, if you use the color pencil, there is no image on the next page. But if you use the crayons as well as you can use the sketch pencils, sketch pens. So what happens whenever you can draw the structure in the booklet? So there is a image. Okay, you will get an image that crosses the next page. So there is some problem will be like this. That's why better to go for only color pencils, right? So remember, the first thing in this case is whenever a polysilicon crosses the diffusion layer, and this diffusion layer may be either P diffusion or N diffusion. Okay, so a transistor is formed. Okay, in the NMOS design style or in NMOS technology, we are having pull-up transistors or depression mode transistors, and pull-down transistors are enhancement mode, N-channel enhancement mode transistors. Okay, so there is a structure. Okay, NMOS design style or in the CMOS design style, we are having pull-up and pull-down transistors. So in the NMOS design style, the pull-down transistor is the N-channel enhancement mode transistor, but in the pull-up transistor is the N-channel depletion mode MOSFET. Remember, this is the most important. So in order to distinguish, in order to identify this depletion mode transistor in the structure, so we are having an implant. Okay, this implant is used to identify the transistor is the depletion mode transistor. So we are using only implant in the NMOS technology only, in the NMOS design style only. Remember, this is the implant because we are using depletion mode transistor only the NMOS design style. Okay, so therefore, in the NMOS design style, in order to identify the depletion mode transistor, we are using the implant. The color for this implant is yellow color. You can draw a dotted line of a square like this. So it is the implant. Okay, by seeing this yellow color or implant, you can identify that this transistor is a depletion mode transistor. Now here, just observe here, there is no implant. That means this is the, by default, this is the enhancement mode transistor, N-channel enhancement mode transistor. This is the N-channel depletion mode transistor. And to identify the N-channel and P-channel, so okay, so this is the width. Okay, the width of the, in case of pencil and pen, ordinary pen and pencil, you can draw the width of this layer is somewhat, actually it is very thick. If it is very thick width in this, width is very thin, then we can say that this is the N-channel FET. Okay, enhancement mode transistor, and this is the width is very somewhat higher than this N-channel width. Okay, so then it is the P-channel FET. Okay, P-channel FET. Okay, there is the identification here. Okay, just see, just observe the figures here in these two cases. Okay, so this, what are the both are N-channel only. Okay, so for N-channel, this is the case, but we are, in case of NMOS design, we are not using a P-channel transistor, right? So therefore, this case, so whenever a polysilicon, this is the polysilicon, width of the polysilicon, depending upon this is the cloud of dots. Okay, this is the cloud of dots. So in case of monochrome style, but come to the color codes, just draw a line. That's all. You take a red color and draw a line, horizontal line. Okay, and take a green color, draw a vertical line. That's all. So then the transistor is formed. We can identify that the transistor is formed in that area. Okay. Similarly, take a green color and draw a vertical line or horizontal line, as you like. Okay, vertical line and exactly perpendicular. Remember, the polysilicon must be perpendicular to diffusion layer. Okay, it may be N-channel N diffusion, or it may be P diffusion. Always it is a perpendicular. Okay, so this, therefore, this polysilicon is perpendicular to this diffusion layer, right? And the polysilicon crosses this diffusion layer here. Okay, so diffusion layer, so the transistor is formed. But this is now we are having the implant here, so this is nothing but a depletion mode N-channel FET, and this is the enhancement mode N-channel FET, right? These are the main things you have to remember. Okay, now let's see the contact cuts. We are having different type of contact cut, the buried contact, and also we are having ordinary contact. So the ordinary contact means metal and any layer. Okay, so we are having an ordinary contact between metal one, always a metal one, and any of the different other layers. It is NMOS diffusion, or it may be polysilicon, or it may be P diffusion. Okay, metal with any of the remaining layers, there is an ordinary contact. Okay, and remember the most important thing in this case. Okay, whenever a contact is made, with the diffusion and also the polysilicon. Okay, diffusion and polysilicon. Remember, whenever the contact is exists with the diffusion and a polysilicon, then we can use the buried contact. Okay, or another one is also there, that is the butting contact. Okay, buried or butting. But compared to the butting contact, buried contact is most widely used. We will discuss what is the butting contact afterwards. What is the buried contact, what is the butting contact, we will discuss. Remember that point here now. Okay, so once again I will explain. So whenever come to the contacts, okay, whenever a metal one with other any material, metal one with N diffusion or metal one with the polysilicon or metal one with the P diffusion, you can use the ordinary contact, that is a black color. Okay, remember black color. You can take a black color and draw a small circle there, that it becomes a contact in the stick diagram, right? Similarly, so whenever polysilicon and diffusion layer, okay, join together. Okay, whenever the polysilicon and diffusion layer join together, at this point, joining point, we are going to use the buried contact, that is the brown color. You can use the circle. Okay, we can use the one circle that is using a brown color. Okay, brown color. And remember another very important thing. So in the transistor formation, there is no contact here. If there is a contact, what happens? The transistor will not form. Okay, that is also a very important thing in this case. And this is the diffusion layer, and the polysilicon crosses like this. That's all. A transistor is formed. And remember, there is no contact. Okay, there is no contact. If there is a contact, the transistor will not form. Okay, there is no transistor formation. So therefore, whenever the polysilicon crosses the diffusion layer, then the transistor is formed. Okay, remember that point, right? So next class, next slide you can show how to draw a stick diagram. Now we'll discuss. Okay, so just observe here. So you know the inverter circuit. Okay, you know the inverter circuit. Okay, this is the circuit diagram of inverter. Okay, this is the VDD line. This is the depletion mode transistor, the N channel. Again, from here to here, the N channel. Okay, remember. And this point here we are having ordinary contact. Here we are having ordinary contact, but this point is not an ordinary contact. Okay, this point is not a ordinary contact. So therefore, remember this point, because I am not drawing here using a brown color, because I am not having the brown pencil here presently. So tomorrow I'll bring it. Okay, so there is no. So this is the brown color. Okay, you identify that one. Okay, so just remember that point. Whenever a polysilicon, this is the gate terminal for polysilicon, crosses, polysilicon touches with the diffusion layer, N diffusion, this point, so there is a contact. So that contact must be either butting contact or buried contact. Remember that point. Okay. So therefore, this is the structure of the how to draw structure of the inverter. Then how to draw the stick diagram. Okay. First, to take this sufficient space between the two horizontal lines. Okay. Draw the two horizontal lines first. So this is the VDD line and this is the ground line. Okay. So first take a metal layer. Okay, metal, what the color code for metal? Blue. Take a blue color pencil, draw a line. Okay, draw a horizontal line. Okay, and similarly use some space, sufficient space, and draw another horizontal line parallel to this horizontal line. Okay, top of the horizontal line, parallel to this one, you can draw another horizontal line. So there is a sufficient space required. Similarly, that is the case. But here in the monochrome condition, you are having a rectangular shape like this. Okay. But now remember, because we are using a color pencils, okay. So this is the blue color. Just take a blue color and draw a horizontal line. Another blue, take another horizontal line you can draw here. There must be sufficient space. And then take a green color. Okay. This is the first condition. First point. Second point is take a green color and draw a vertical line, because okay, just see here. This is N diffusion. Okay, N channel. This is also N channel. That means from drain to source, again drain to source, totally a channel. What type of channel this one? N channel. Okay, this is totally N channel. For this case, we are having totally a N channel. That means N diffusion layer. Take a green color and draw a vertical line between these two horizontal lines. Okay, these two are the blue color. Draw a horizontal vertical line. Okay, this is the N diffusion, we can say. Similarly, now just see, this is the pull down transistor. When the transistor will form, whenever a polysilicon crosses the diffusion layer, a transistor is formed. So here we require one polysilicon, it must cross the diffusion layer. Similarly, here also we require one polysilicon, it must cross the diffusion layer. So therefore, that is the case. Okay, just take. So you take a polysilicon here, cross it. Okay, then just see this is the crossing. Okay, when there is no extension of this polysilicon, then the transistor will not form. Okay, when there is no extension of this polysilicon, no transistor is formed. So to form a transistor, the polysilicon must cross this diffusion layer. Okay, that is the most thing. Okay, remember. So this is also having some dimensions in the layout diagram. We'll discuss there. Okay, so this is the polysilicon crosses the diffusion layer. Now this is the enhancement, the transistor form here. Okay, so this is the enhancement mode transistor because you are not having implant. Similarly, now just observe here. So this is the gate of the transistor. So from the gate of the transistor, we are having this point be connected to here, source of the EPC mode transistor. Therefore, gate is identified. Gate is used to identify. Polysilicon is used to identify the gate, right? So therefore, the color for this polysilicon is red color, right? So take a red color, okay, draw a line like this, okay, draw a line. So this is the formation of the transistor here because the polysilicon crosses here, okay. This is the polysilicon transistor will form, but the gate of the transistor is short circuited to the source terminal. Okay, here we are going to join the different layers. Okay, this is the first thing. Next condition is this is the depletion mode transistor. Place an implant. You can take a yellow color, draw a dotted line like this. Okay, if it is a you are using a pen and pencil, white paper and pencil, you draw a cloud of dots. Polysilicon is nothing but the cloud of dot we are using here. Okay, and these are the vertical lines, right? So this is the implant. This is used to identify the depletion mode transistor in the NMOS design style. Okay, the color for this implant is yellow. Okay, that is the case. That is the main important thing in this case. Okay, similarly, we form a transistor. So this totally. Then the final step is contacts. Okay, this is the metal one, and this is also a metal one. This is the polysilicon. This is the diffusion layer. So metal with any layer, you can use the ordinary contact. Okay, you can use the ordinary contact. Basically, the colors it is a black. Okay, similarly, here also a normally black color. Okay, this is also black color. Okay, so is metal and diffusion. A contact will be exist. So, but come to here. Okay, come to here. What happened? Polysilicon crosses. Polysilicon crosses N diffusion. Okay, sorry, not crosses here. Polysilicon. 1 minute. Okay, whenever a polysilicon crosses okay, so whenever the polysilicon, just this is the ordinary contact, and this is the polysilicon when the polysilicon join with the diffusion layer, we are having a buried contact. Okay, this is the brown color basically we are using. Okay, that is about the stick diagram. These are the steps to draw the stick diagram in this. Okay. Next, just see here. Now we can draw the everything. What are the topics I discussed now. Okay, the same thing we can draw here. Okay, so in case of to draw a stick diagram in NMOS design style, we are having different layers. That is N diffusion, Kinnox or transistor channel can be represented by green color, polysilicon red color, metal one blue, contact cord black, implant is yellow, buried contact is brown. Then see, this is the structure, the schematic of inverter. Okay, NMOS inverter. So we are having input A, output we are having here A bar. Okay, this is the one transistor, enhancement mode transistor. This is the displacement mode transistor. So first you draw a horizontal line by using a blue color. Under horizontal line, there must be sufficient space. Okay, there must be sufficient space. Okay, then this is the N, totally N channel. Take a green color and draw a vertical line. Okay, draw a vertical line. 1 minute, amma. Okay, so this is the different type of polysilicons, right? Now let us consider. Okay, now let us consider. Okay. So now this is the, just draw a horizontal line by using a blue color. Under horizontal line, there must be sufficient space, and then the polysilicon crosses the diffusion. Just see here, the polysilicon crosses the this vertical line. There is a diffusion line. A transistor is formed. By default, this is the enhancement mode transistor, N channel FET, because the color green is used to identify the transistor N channel. Okay. Similarly, another polysilicon crosses the diffusion line. Green color, a transistor is formed. Okay, a transistor formed, and extend this polysilicon, because you see here gate is directly connected to the source terminal. Okay, extend this polysilicon up to this line. Okay, here another contact we require, and remember, because of presence of this contact, so what happens? There is a connection for output. Okay, when there is no contact, this will crosses again transistor, another transistor form here. Okay, so here we require a contact card. Basically, it is a brown color. Okay, don't forget here, this is the brown color. And then in order to distinguish this transistor and this transistor, we are having implant. Okay, the color for this implant is yellow. Draw a dotted line exactly around the channel. Okay, around the, this is the channel point, crossing point of the transistor. So around this crossing point, we are having a implant, place a implant. Okay, so this implant is used to identify the depletion mode transistor, right? This is the contact, another contact, and this is another contact. So from here, you can take either polysilicon, or you can take from this contact, you can take metal one, or from this contact, you can take a diffusion. There is a green line. Also, you can take the output from here. Okay, you can follow any method because this is a contact terminal. Okay, blue, metal, and then blue means metal, polysilicon, red color, or you can use depending upon our application where we are connecting this output terminal. Okay, so remember, this is the stick diagram of the inverter, right? So next, so draw the stick diagram for NAND gate. Okay, this is the schematic of the NAND gate. Already we discussed the last class how to draw the schematic. Now once again, so this is the VDD line, this is the ground line. So VDD and ground line is nothing but metals. So therefore, conductors, perfect conductors. Okay, therefore the conductors are nothing but the metal layers. So take a blue color, draw a horizontal line, and again draw a horizontal line. Okay, we are having, there must be sufficient space. Okay, to draw the remaining circuit. Okay, and this is one transistor, this is another transistor. Take a red color, draw a horizontal line like this. So one transistor form here. Okay, this is one transistor formation. Okay, just cross this point. Take another to form another transistor here, because these two transistors are connected in series. Okay, on the same channel line, on the same green color, there is the same N diffusion layer. So this is the series connection. Okay, just remember, this is the series connection. So take a green, red color and cross the diffusion layer. So this is one transistor is formed, this is another transistor is formed. This is the drain, this is source. Okay, drain, source, again drain and source. Drain and source will be joined together. So drain and source will be joined together. So this is the series connection, we can say. Okay, and this point will be extended to here, this point. Okay, And here another form, transistor is formed here. Take a red color and draw a horizontal line and must cross it, and then extend this polysilicon to this point and make a contact. Okay, and this is the output terminal. So there is the depletion mode transistor. You take a implant yellow color. So then you can identify that this is the depletion mode transistor whose gate is short circuited to the source terminal, and these are the enhancement mode transistors. Okay, and make a contact here, another contact. These two contacts must be ordinary contact. Okay, metal one with diffusion, but this is the special case, poly with diffusion. So this is the buried contact or butting contact. So buried contact basically we use. Okay, so the butting contact, this is a brown color for the butting contact. Okay, remember these are the point, and take a red color and extend to this one. So not only extension in this point will be connected to the output terminal. Okay, it may be a diffusion layer, green color, or metal one, or polysilicon, right? This is the stack diagram for NAND gate. Okay, VDD line, ground line. Okay, next we can go for the NOR gate. So these are two transistors connected in parallel here. One transistor is depletion mode transistor connected to the output terminal, right? So now to draw the stick diagram for this one, again once again the process is same. Draw the two horizontal line by using a blue color. Okay, by taking a blue color here, and just observe now here. Just see the NOR gate structure. Okay, see the NOR gate structure. This is N diffusion. Okay, N channel. This is also N channel, and this is the drain point joined together. So you take a green color, draw the same structure like this. Okay, draw a structure in the same method. This is the method. Okay, and then take a point from here, again green color, draw a vertical line. Okay, because you are having a structure like this. Okay, you're having a structure like this, so we are having this type of structure. Next, here we require one transistor formation. So take a red color, join it, we'll get a transistor form. Okay, A transistor will be formed here. Similar, another transistor we require B, cross it. So there must be some crossing. Another transistor is formed. So another transistor we require here. Just cross the polysilicon and join these two terminals here. Okay, so and place the implant. Okay, this is depletion mode transistor, and make a contact. Wherever a contact is required, make a contact. Okay, this is the brown color. Okay, A bar. So this is the NOR gate function, right? So that is about the structure. Next, you can go for the next case. You take any Boolean function. Okay, let's go A plus AB plus C whole bar. Okay, because these are the inverter based circuits. So therefore, the inverter based circuits we are going to use bar in this case. So now in this case, this is the depletion mode transistor A, B in series, parallel with C. Okay, once you draw the structure schematic, the same method, draw a stick diagram. Okay, so this is the N channel. So diffusion you can take from here. Is the N channel, again diffusion in green color. Form a transistor by placing red color. Again red color crosses this point. Another transistor is formed. Another transistor is formed here in this case. You want another third transistor, you can just draw a line, that's all. Okay, take a red color, cross it. You get another transistor to form like this. Okay, and same method for this case, this is the output point. Okay, contact, again contact, contact, and contact. Okay, that is about the stick diagram. That is the NMOS design style. Okay, so NMOS design style means how you are drawing, how you are going, what is the procedure to draw the stick diagram. Okay, that is called NMOS design style. What are the conditions we are having? What are the conditions? What are the things? What are the layers? What are the color codes for the layers? Everything you can mention as you want. There is nothing but NMOS design style, right? There is the, remember this point. This is the structure of stick diagrams. Okay, these are known as stick diagram. That means just see, remember here. So we can convey the layer information. These are the different layers. We are going to convey the layer information by use of the color codes. Okay, these are the color codes you are using. So by seeing these color codes, we can identify that this is the transistor structure. Okay, so therefore, this is called the stick diagrams, right? So that is about the NMOS design style. Okay, in the next class, we can go for the CMOS design style. Okay, we can go for the CMOS design style in the next class. Okay, so I'm going to stop the screen now. Okay, goodbye.